I'm Nick from vireengines.com, and today I'm going to show you how to fit on a late coupling type the new uprated rubber coupling. This is only really necessary if in the unlikely event you've torn this rubber or you want to replace it or you've lost it, but here we go. Now this fits the early couplings easily, but it's a little bit more difficult on the late coupling. You just need to stretch it a bit wider to get it over the studs, and I'll show you the technique. Now if you get this from me, order the kit, because you get these extra parts with it. You get 3 bolts which you can use instead of the long M10 studs. It makes it easy to fit, and you get some pair of nuts to remove the old M10 studs, and finally get some nice bushes and washers so that when you reassemble it, you won't have a problem with the nuts being too big and getting recessed in there. And I'll show you how to do it. So basically, if I just pan out a little bit, the tools you're going to need are quite simple. You've got a 17mm spanner, a 13mm spanner, so that's for the nuts on the both sides of the coupling, and correspondingly some sockets which you've got 17 and 13 with an extension as well. So hopefully that's all we'll need, and a little bit of technique and effort to stretch it over. So we'll go back to this shaft. I just point out as well, this is a Vire 12 engine. It's exactly the same coupling on the late models, and the idea was that if the engine went into full reverse, this metal flange would stop the two halves separating and ripping the rubber. The rubber is quite weak and wouldn't take that. This rubber is 10 times stronger and can take that. The downside with this design was it had more vibration in it as well. So this is a Vire 12 horsepower model. You can see by the Bing carburetor it's a 12, and also the spark plugs on the front. If you've got a Vire 7, the spark plug will be on the back, and you'll have a Tillotson carburetor on the side. But the coupling is exactly the same. As I say, they designed this to stop the rubber coupling splitting in full power reverse, but the problem is this metal flange could vibrate, and it makes the whole thing a lot stiffer, so you get a bit more vibration in the boat, and that's not really a great thing. So when we've done this, we're going to be discarding this metal plate, and that should make it a little bit more vibration free. So I'd like to point out that you should have on any boat with a prop shaft a circlip on your shaft, and the reason you've got this here is because if this joint fails, which is a squeezing compression joint, I've not got the bolts in here at the moment, but these should be tight. If that shaft slips out, I had one customer, another one I heard of, and what happened is the boat was travelling forwards. They put the engine into reverse to brake for the marina. The rearward thrust of the propeller pulled it out of its socket here because it wasn't tight, and because the rudder didn't stop the propeller, the whole shaft disappeared out the back of the boat, leaving a 1-inch hole which vigorously started flooding the boat. And in both cases, luckily, the owners were realised that they were close to shore and it was flooding, and beached the boat before it sank. But the lesson in this is always have a circlip on your shaft, so that if it decouples from the clamp, it will hit that circlip before it goes out of your stern gland and break it at that point. So a cheap trick, and that's what you should do. So we'll zoom in and we'll do this job now. I hope you find these tips useful. It could save a big drama. So first thing we're going to do is we're going to tackle these 17mm bolts on the back. In this situation they're a little bit stiff. If you need to break it, what I suggest you do is you can either jam a spanner between the ear and the hull, or you can put a screwdriver in this slot, or brace around some other method to stop the shaft turning. but in this example these are not on super tight and I'll be able to get them off, hopefully. Let's try the tube spanner. Yeah, that goes on. And then I can use the 17mm spanner on one of the others to stop it vibrating. This is why I suggest you have a pair. Don't take the nuts all the way off. You want to get all three loose before you take the last one off. And if you think about it, that's right. That's two loose, one more to loosen. These are loose. So if I had a flat blade screwdriver in that slot, that's one of the techniques I've used on a boat. Another technique I've used is to get a wooden block. I'll show you. So if this is in the boat, what you would do is you get a wooden block here and you would jam it between one of the ears of this gearbox coupling and the boat, and it would stop it from turning round. I do it on that port side, and it's going to stop it turning, effectively locking the shaft. Right, once I've got all three loose, let's take off the nuts and the washers. You might not have washers. You might find that these obstruct the exit of some things, so you may want to use a 6mm Allen key to take off these 4 bolts, but remember to tighten them up afterwards, of course. Like I say, you don't want to lose the shaft. Right, finally this will come off as an assembly. Okay. And where we have the plate, which I'm going to discard, if I've loosened these screws, you would take the shaft out, push that back. Obviously I'm not in a boat, but you can imagine. And then you've got this ring, which you can discard, and this piece of rubber, which you also discard. Not going to be needed anymore. And then you've got, hopefully, some bushes already from your old coupling. 1, 2, 3. And discard those. And then finally you've got the prop shaft side of the flange held on with 13mm nuts. So we're going to take those off. So shall I just zoom out a bit, Nick? So do those. The same thing applies with this. You can use one to brace the other until you've got it nice and loose. Second tube. And 3, I can just put it on my lap. Okay. Take all of those off. This is real time, by the way. I've not speeded this video up. If you know how to do that in a few clicks, let me know and I'll do it for you in future. So you'll notice the difference between the old coupling and the new one is that the old one has got 6 holes, but 3 of them this should just pull off. If it's rusty, then you may need a screwdriver just to separate the two. So here's your old coupling, and the distinguishing thing was they had 3 larger holes for the M10 bushes and threads, and we can't get these anymore, and they were too weak. They were made of some rubberized piece of cloth, believe it or not, and that's why Vire designed it with all these flanges instead. Now the new one what you will do is you will stretch it on to the rear of the engine first, and then you'll be able to plug this easier part in. As you'll see, that goes fairly easily onto the aft thing. So we'll do the difficult side first and then the easy side. Now basically you're just going to have to use some muscle here and put this over. It doesn't matter which 3 holes you use. I suggest you get the top engaged first. A little bit of grease would help. Make sure that they're nice and clean of rust and dirt, these studs. But you see, if I just push this down equally, that's going on now. Once I've got it on all right through the threads, that will be even easier. So just pulling the rubber down a bit helps me to get it on the threads. There we go. And gradually push it on towards the engine. Okay, that's going well. If you've got the bushes on these studs, take them off, and any rust that could interfere with sliding is on clean as well. So that's the first half done, and the second half is just as easy. You will slide back your shaft, or in this case I've taken the coupling off, so I can put this into position. A little less stretching is involved in this half. What you'll find is if you need to pull this out slightly, a screwdriver in between the hub here and the rest of it will ease it out. I'll show you how to do that. So I've got here a large screwdriver. It's got a nice flat head which is about half an inch wide, and if I put the tip between this metal flange and the rubber, I can twist the head and push the bush outwards a little bit that the stud is going to go through, and that will help it to line up. So let's just get the bottom two engaged. So it's not super easy, but it will go. There is enough stretch in this, don't worry. Another tool which I think is helpful is some pipe pliers, and you can use those to squeeze the two halves together. So pipe pliers are these sort of adjustable things. They're quite nice, and what you can do is you can adjust it just slightly less than this distance here and squeeze, rotate, and that will go on quite easily. There we go. Keep turning a few millimeters at a time. And I'm getting to the point now where I need to reduce the slot width of these pliers. Once you've got the studs all the way through, you can use the nuts to do the final bit of tightening. Okay, right, that's that. So that's now all of the holes filled with the studs correctly. Now on the rear side you've got 3 bushes, and you pop these bushes on the 3 studs, and this is so when you've tightened up your nuts you can still get the spanner on the edge, they don't sink into these holes. And then you've got 3 washers, either the ones I supplied or the ones you had originally, just to reduce the friction on the bush as you tighten, and then you replace with your 3 17mm studs, nuts. 1, 2, 3. Where are we? There it is. Okay. On the opposite side, you've got your washers, which I've supplied as well. And I like to do these washers, if you look carefully, there is there's 2 sides to washer. There's like the smooth side and the sharp side. It's the way that they're pressed out, and I like to have the smooth side facing the rubber, just so if there's any distortion it can't act like a tearing thing. So you have 1 washer, 1 nut on each of those. Like so. Oh, where's number 3? Whoops, let me just get another washer. Two for luck. Right. Washer, smooth side facing the rubber. Nice new nylock stainless steel. And then all we're going to do is tighten these up. So, I mean, you know how to tighten nuts up. It's the same procedure. When you get near to the point where they're absolutely tight, what you want to do is use one of the spanners or one of those techniques to stop the shaft rotating. You want it a little bit tighter, and you could probably hold it by your hand. Okay, so that's that side. On the opposite side, we're probably going to have to go short. Set. Right, and then to do the final tightening, what you want to do, because these are opposite directions, is hold the shaft from rotating, use a 17, do the 13s up. That's fine. So that's all the 13s tightened, and then just check the tightness of the 17s. If it's not going to vibrate loose, it's tight enough. You don't want to make this a ridiculous torque, because it's just going to make it more difficult for the next people to service it if they need to service the engine. And then if you've slid back your shaft, as I have, you put that back in to the same position it was, and then you would put your 4 bolts in to tighten it up. So the assembled rubber, you can see it's actually got quite a lot more flexibility than the original unit had, and that's important because when you put your engine in, it's not always absolutely straight, and the shaft, if it's very stiff, it's going to be bending and rubbing against your prop shaft bearing, which gives you the vibration, whereas if you've got the designed flexibility in the drive shaft, that will cope and take most of the vibration out. So I'll just extend this video a little bit now, and I'll show you the other technique which is possible. And if you want to use these bolts, you can replace the M10 studs completely. Okay, this is the method I prefer, which is to remove these